Hello, so we're going to go ahead and go over part 2 of the 2021 final part 2 of the review. Okay, so on this one, remember it says find the point that divides segment AB 1/3 of the way from A to B. So we're going A to B. So we're going to do our triangle. Okay, everybody, so remember we're going to do that. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3. So that horizontal distance is 3. 6 times 1/3 is going to give me 2. 3 times 1/3 is going to give me 1. So I'm going to go down 2 over 1. And that will be my new point. So that new point would be at -3, 2. Okay. So this says divide the segment that is halfway from A to B. So we have to graph them. Okay, so we're going A to B. And we're going to do our triangle, our right triangle again. So 1, 2, 3, 4. Point C. And up 2. Half of 2 is going to be 1. Half of 4 and it's going to give us 2. So we are going to go over 2. Up 1. And that will be our new point. So our point is going to be at 1, 2. Okay, so this one it says find the segment. It is 3/4 of the segment the way down. So we graph the points. So 2, 1 for A, and 2, -3 for B. We're going 3/4 of the way, so I'm going to go 1, 2, 3 right there to 2, -2. And that would be the new point. Okay, this one from A to B. Okay, so we're going to go, and it's 2/5 of the way. So I'm going to go over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 up. 5 times 2/5 is going to give me 2. 5 times 2/5 here is again also 2. So we're going to go over 2, up 2. So this is everybody, you definitely need to read A to B, and our new point would be right there. So it's going to be at 1, -1. Okay, this one is a dilation of scale factor. It is shown, so remember we could use a straight side. So this is 1, this is 3. 1 times our scale factor is going to give us 3, and I know 1 times 3 is going to give me 3. So our scale factor is 3. So scale factor is 3. And there's center of dilation. So remember that's when we use the points. So we go like this. From our center. And our center of dilation would be right there at 3. Sorry, not at 3. -4, 3. Okay. So this one is also going to be scale factor. So this would be 4. This would be 1. 1 times our scale factor is going to give us 4. So 1 times 4 is 4. So our scale factor is 4. Okay. Oh, sorry, we're actually going the other way. So we're going from 4 to 1. Silly mistake, but that also means that we need to watch it. So that means that instead of 4, it's going to be 1/4 or 1/4, which was 25 cents, which is 25%. Okay, and then for our center of dilation, So we're doing from A, C, and from B, and it's right there at 2, 1, 2, 1. Okay, so this one more. Okay, so this one we're doing dilation again. So finding the scale factor. So with this one, everybody, we could use a coordinate. So I could look at C. So C is at -2, 0. And C prime is at -1, 1. So you go, okay, -2 times what is going to give us -1. And we go, okay, it's not going to be 2. Think about a point. Okay, because if we look at B, B is at -3, 1. B prime is at 3. Well, B, sorry, 1. B prime is at 3. 3. So we're multiplying by 3. That's what it looks like. But our center dilation, everybody, definitely would be there. So that would be at -3, -1. I say it's by a scale factor of 2. It's going up. Okay, so on this one, because it's getting bigger. Okay, so this one's going to be the scale factor. Okay, so this one easy because we have a nice straight side. So this is 3. This is 1, 2, 3, 4. Okay, so then that's going to be 3 times what is going to give us 4. So we can actually take and divide each side by 3. So it would give us not exactly that. Okay. It would be 3/4 is 3. It's actually going from 4 to 3. It's getting smaller. Apologize, everybody. Okay, so 4 to 3. So it's getting smaller. So we have that. So it was definitely getting smaller. So this one would work. So 3/4. Because 3/4, everybody, is equal to 3/4. And 4 times 3/4 is going to give us 3. Okay. Center of dilation for that one. Pretty easy with this one. So we do that. You do A. Do the same thing with C. And it would be right there at 2, -2. Okay. Rotate the shape and find the volume. Okay. So so this would be a cylinder, everybody. Okay, so this would be the height. This would be the radius. So our volume of a cylinder is pi times radius squared times the height. So volume is going to be equal to pi times 2 squared times our height. We put that all in the calculator. So everybody remember, think of drill bits for these as far as the shapes. So so we get 62 and 83. And we'll say it's centimeters. And put units on here. Okay, so this one would be a cone. Remember, think of drill bits, everybody. 4/3 pi. The base is a circle. So that's the radius. This is the height. So 1 divided by 3 times pi times 6 squared times the height. We get a volume. We're going to round to the hundredths place. Remember, everybody found 5 and up rounded up. So look at the number after. Okay, and we'll use centimeters again, just because we like centimeters. Okay, this one would be a sphere. You rotate it around. This is the radius. Volume for a sphere is 4/3 pi times radius cubed. 4/3 pi. 3. Remember, that's going to be raised to the third power. So 4 divided by 3. And we get 113. And 5, then I've rounded up. Okay, describe the cross section, everybody. So remember, look for the purple. So we look for the purple in this, everybody. Look for the purple part. So it'll be purple, so it's a triangle. Okay, so we're naming the 2D shape. Okay, so this one is also a triangle for the cone. And this is our triangular. No, it's actually a square pyramid. Okay, for this one, it would be a rectangle for a hexagonal prism. Not prism. Yeah, prism. Rectangle. Okay, so everybody remember, look for the purple in those. Okay, and you're looking for that 2D shape when we cut it. Like when we cut like an orange or an apple. Oh, perfect. I just said like we cut an orange or an apple. So like this one. So it would be a circle. And this one. 1, 2, 3, 4, 5, 6. Checking. It is a hexagon, not a heptagon. Okay, so this one. What solid is created by revolving around? So it would be a cylinder again. Okay, so this would be the radius. This would be the height. So volume is pi times the radius squared times the height. Everybody writing the formula out just helps you remember what you're supposed to be doing with this. So we do pi times the radius times the height. And we get volume is equal to 141 and 37. And we'll just say it's centimeters. Okay, for this one, what's solid? So it's a cone. Okay, we actually don't need this, everybody. That's the slant height. Okay, so we don't need slant height in this case. We would if we were doing anything with surface area, would need it. So this would be the radius, and this would be the height. This would be the radius. Jumping ahead of myself. Just already looking down there. Try to make choose a different color. Okay, so this is going to be 1/3 pi times the radius squared times the height. So the 1/3, remember, you can do is 1 divided by 3. Remember to use the pi key, and it's going to be 3 squared. So 3 raised to the second power times the height, everybody, so we're multiplying those all together. So we're going to get volume is equal to 37 and 7 centimeters cubed. Okay, this one, everybody, I rounded up to that one because we get 995 and up, rounded up. This means we would round it up to the tens place, so that's why this would be our final answer. Okay, so we round this up to the tens, this up to the sevens. Okay, ooh, density, we love density. Everybody remember that we love density. Okay, so it's mass divided by volume. Okay, rectangular block has a mass of 1,696 grams. The dimensions of the block, oh, we're not quite done. So remember, it's going to be, it's a block, so length times width times height, rectangular prism. So we're going to have to multiply those all together first, everybody, to find our volume. Then we can do our multiplication. So multiply all three of those together, length times width times height. And we get 2,530.8. So we love mass, mass divided by volume. So we get density is equal to 6, 5 and up, rounded up, so it'll leave it as 8 grams per cubic centimeter. Okay, so this would be cubic centimeter, and these are grams. Okay, find the mass of benzene. So for mass is going to be equal to density times the volume. Okay, so we're going to do the density, and we do use all the numbers. So 0.9765 times the 150 milliliters. Remember, liters tells us that it's volume, as well as cubic units. So mass will be equal to 146, 5 and up, rounded up, so I rounded up to 48 grams. Okay. Volume of silver has a mass of exactly 3,500 grams. Density of silver there, so they give us that. So volume is going to be equal to mass divided by the density. Okay, so so we put it in, so it's going to be 3,500, 12.5, 195 and up, rounded up, 97 cubic centimeters. So I know it's cubic centimeters because the unit's there for density. Okay. Okay, almost done. Last page. Just so you know, there are the formulas for volume just right down here, in case if you forgot them. Okay. So, but remember, you can also use a formula reference sheet. Everybody remember we have this sheet that you can use. Okay, so a block of lead has these dimensions: length, width, height. So we're going to multiply those all together to calculate the density of lead. So I'm going to multiply all these together. Okay, so remember the volume is going to be length times width times height. So we get 238 and 7/10, and then we have a mass of 1,087 grams. Remember, density is equal to mass divided by volume. So 1,487 grams divided by 287.7. And 5 and up, rounded up. So rounded up to 3. So 6 and 23/100 grams per cubic centimeter. Okay, because this unit is cubic centimeter. Okay, cylindrical tube has a length of 15.4 centimeters and a radius of, so it's a tube, okay, radius of 2.5, and it's filled with colorless gas. If the density of the gas is known to be, what's the mass? We're solving for mass, okay, but we're going to have to get volume first. Remember, that's going to be pi times the radius squared times the height, so pi times 2.5 squared times 15.4, so pi times 2.5 squared times 15.4. Okay, so we get 302.38, and that's going to be centimeters cubed. Okay, so our mass is equal to volume times density. So we're just going to do 302/3800 times 0.002235. So our density is 0.67 grams. Okay. What is the mass? If ethanol alcohol is filled by containers, the 250 milliliter container density. Okay, so remember, mass is equal to volume times density. So we're going to multiply the 250 milliliters times the density, 0.598 grams per milliliter. So we multiply those together, everybody. Okay, so that would be our mass. What's the volume in the square pyramid of this attic? Okay, so volume, remember, is going to be 1/3. Area of the base. Again, everybody, this is the area of the base. Okay, so this is the area of the base of the floor is 130. The height is 5. So we do 1 divided by 3 times 130 times 5. So we're multiplying those all together. And we get 206.67, 5 and up, rounded up, everybody. And that would be meters cubed. Okay, so this one, square base again. Height of the attic is 4 meters. The area of the base is 350. 1/3 times the area of the base times the height. So volume is going to equal 1 divided by 3 times 350 times 4. So we get 496, 5 and up, rounded up to round up to 97 cubic meters. Okay, we got it, everybody. Good luck. Take your time, write it out.